Evaluate one-sided limit when you see x approaches to a number. If you see a minus in the upper right-hand corner, that means the left side. If you see a plus, that means x approaches to that number from the right side. So first problem is limit of 1 over x, x approaches to 0 from the right. For one-sided limit evaluation, there are a few popular techniques. Either you just plug in the x, you simplify the function first, and then you plug in x, or you use table values to support your work, or you draw a graph. Okay, so the first one, we have limit as x approaches to 0 from the right-hand side, 1 over x. So 1 over x, we cannot plug in 0 to x, right? Because when you plug in a 0, 1 divided by 0 is undefined. So this one, let's check the table value. So I'm going to set up a table, x, and then this is 1 over x, and then I am going to pick some value that is very close to 0. So 0 plus 0 on the right hand side. So let me give you a picture of 0 from the right hand side. So what does that mean? So you have a 0, this is a number line, so this is right hand side, right? And then x approaches to 0 from the right, that means you are going to pick a number that is just a little bit greater than 0. So what kind of numbers are a little bit greater than 0? So we can try this. So 0.1, 0.01, and then 0.001, and then 0.30, and then a 1. And then you plug in each of these number to the function to see what happened. So when you plug in a 0.11 divided by 0.1 is equals to 10, 1 divided by 0.1 is equals to 0.01 is equals to 100, 0.001, you get 1,000, and then 30, that gives you a 10,000. So that means as x approaches to infinity, so if you are making this number, let me take that back, as x approaches to 0, from the right hand side, do we agree that this number is getting closer and closer to 0? So as x approaches to 0 from the right hand side, what happened in the y value? Y approaches to infinity. So the number is getting very, very large. So let's take a look at 1 divided by 0.01. So 1 divided by 0.01. Or maybe we should try this, 1 divided by 0.1. So let's put this to a fraction. So 1.1, that means 1 divided by 10, right? If you take 1 divided by 1 over 10, you do the reciprocal, then that is 1 multiply 10 over 1, so that is equals to 10. If you do 1 divided by 0.001, that is 1 divided by 1 over 1,000, you take the reciprocal, the answer is equals to 1,000. So if you put many zeros before the 1, then you are taking 1 multiply an extremely large value. As a result, the y is getting really, really big. So let's draw a conclusion right here. So if you have a real number divided by a number that is very close to 0. So number close to 0. As a result, you get an infinity. All right. So what is the limit equal to? The limit is equals to positive infinity. So for positive infinity, usually they will just call that the limit does not exist, because we are not positive infinity. It's not a real number. We are not able to determine what y approaches to. Y approaches to infinity, but infinity is just a number that is extremely large. There is no way to write such a number on a piece of paper. So we call this does not exist. So we call this DNE. All right. So take a look at number 2. So number 2, we have x plus 5 divided by x squared plus 1. Let's do this in another color. So number 2, we have limit as x approaches to 0 from the right, x plus 5 divided by x squared plus 1. There is no way to factor the denominator, so the only thing you can do is you can plug in the 0. So if you just plug in the 0, I don't think the 0 will mess up the function. So you will just get 0 plus 5 and then 0 plus 1. As a result, the limit is equals to 5. So it's safe to just plug in. All right. And then the next one is the square root of x. So let's do that. So we have a limit as x approaches to 0 from the right, square root of x. So should we use a table value? Let's try. How about this? Let's try a graph first, and then we do the table value. So for the graph, what is square root of x? So square root of x starts at the origin and then looks like this. So as x approaches to 0 from the right, you can see that as x approaches to 0, follow my cursor. So starting right here, so we are approaching 0 from the right hand side. So y basically approaches to 0. So the answer is equals to 0. Let's look at the table value. So we are going to do this. So x and then square root of x. So we pick number that is very close to 0. So let's say a 0 0.1, 0 0.01, and then 0 0.220. And then you can try the 30, so on and so forth. So if you take the square root of 0.1, you get 0 0.3162, 0.01, 0.1, so this is 0 0.0316, this is 0 0.01, and then if you try one more, 40, that is going to equal to 0 0.0032. So as you can see, as x approaches to 0 from the right, the y value is getting very small, right? So y basically approaches to 0. As a result, the limit is just equal to 0. Okay, so how about this? What if I have limit as x approaches to 0 from the left? Is this possible? What is x approaches to 0 from the left? That means we have a number that is slightly less than 0. That means that number is negative. Is square root of negative defined? No. Look at the graph. Do we have any graphs on the right hand side of the right axis? No. So that means this does not exist. You cannot evaluate the square root of negative. Okay, the next one is ln. Switch to another color. How about this? We never used this before. So we have limit as x approaches to 0 from the right. We have ln x. Alright, ln x. This one is very similar to the previous problem. You can just draw a graph. So for ln x, this is ln x, right? So we have a vertical asymptote, and then we have this. So as x approaches to 0 from the right, what happened? Y approaches to negative infinity, right? So if the result is negative infinity, we call this DNE. DNE stands for does not exist. For this problem, you can try using a table value. So if your instructor asks you to show works during the exam or quizzes, you can show a table value. I am sure that you will see something similar to the square root of x. All right, so let's do the last problem. The last problem is we have a limit as x approaches to negative 3. We have x minus the square root of 3 plus x. So this one I think is safe to plug in. So we have negative 3 minus, and then 3 minus 3, right? So we have a negative 3 minus a 0. So as a result, that is equals to negative 3. All right, so that is the end of this video. If you think my instruction is helpful, give me a like, share the video for me, click the subscribe button if you're on your way out. I appreciate for your help and support. I will catch you all in the next video. Signing off for now.